Okay, on this one we need to find the fourth roots of -4, and we're going to write them in a plus bi form. So we write this as z to the fourth equals -4. We put that in an Argon diagram, and 1, 2, 3, 4. We see that the magnitude is 4, and so we can do cis, and this rotation is pi, as well as circling around some more, so we can say k plus k 2 pi, where k is an integer. Okay, from here we raise both sides to the 1/4. Just going to look like that, so we get z. Now 4 to the 1/4, we could think of that as 4 to the 1/2 raised to the 1/2. 4 to the 1/2 is just the square root of 4, so that's a 2. So it's 2 to the 1/2. So I'm going to simplify that right here. And then right here, I'm going to use de Moivre's theorem, and so that's going to be cis 1/4 like that. And then we can rewrite all of this. Alright, from this point, we want to plug in k equals 0, 1, 2, 3. So if we plug in a 0, it's just pi fourths. I'm going to change that to square root of 2. If we plug in a 1, this is 2 pi plus 1. So that's square root of 2 cis 3 pi fourths. And then it's just going to continue by 2 pi. If we plug in a 2, it's a 4 plus 1, so it's 5. Plug in a 3, it's 6 plus 1, so it's 7. Okay, now if we look at these individually, just remembering that this is cos pi fourths plus I sine pi fourths. That's going to go over here. Pi fourths is square root of 2 over 2, square root of 2 over 2. And so that's what we're left with. So 2 square root of 2 over 2 plus I square root of 2 over 2. And this one, remember, it's square root of 2 cosine 3 pi fourths plus I sine 3 pi fourths. And so 3 pi fourths is going to be, if we estimate where it's at, so if we think of this as 0 or 6, 1.5, 3, 4.5, it's going to be 6 over 4, which is 3 over 2, which is, 6 over 4, which is 3 over 2, which is 1 point. Alright, I believe it's this one, so let's try that. So 3 pi fourths minus pi halves, which would be times by 2 times by 2. So 3 pi minus 2 pi over 4, so that is pi fourths. So it's square root of 2 over 2, square root of 2 over 2, but the x value is negative. So this is square root of 2, negative square root of 2 over 2, plus I square root of 2 over 2. Alright, and then since we know they're evenly spaced, this one's going to be down here. So it's going to be, I'm just going to skip some steps, but this would be negative square root of 2 over 2, negative square root of 2 over 2, so it's going to be negative square root of 2 over 2 minus square root of 2 over 2 I this one is going to be where right here, where the x value is positive, but the y value is negative. Square root of 2 over 2 minus I square root of 2 over 2. Okay. Now, we need to distribute the square root of 2 to all of these. So that's just going to be 2 over, so it's going to give us 2 over 2 plus I 2 over 2. And that's going to be 1 plus I for that final one. Do it here, it's just going to be negative 1 plus I. Do it here, it's going to be negative 1 minus I. And do it here, it's going to be I, or 1 minus I. Okay? Now, part B says, hence write, let's see if I have some room so I don't have to erase. Okay. So it says, hence write z to the fourth plus 4 as a product of real quadratic factors. Okay. So what we're going to do is basically write a polynomial. Let's see, what did it want again? Hence write as a product of real quadratic factors. Okay. So it wants us to do like ax squared plus bx plus c times dx squared plus ex plus f. So our final answer, it wants it to look like that. Basically something like that. Okay. So we're going to get our conjugate pairs together. So we want our i's to be different, but okay, so this one and this one are conjugates. So 1 plus I times 1 minus I. And then we'll do this and this. So we'll do negative 1 plus I. Actually, let's do it over here. Negative 1 minus I. Okay. So what we're going to do, multiply that out, or not multiply it out. These are our, I wrote this a little bit wrong, but we're going to say x minus this, minus 1 minus I, and then x minus 1 plus I. So writing it in factored form. And then I'll do x plus 1 minus I, x plus 1 plus I, and we'll multiply those out. So x times x is x squared minus x plus xi minus x plus 1 minus I, and I'll write them kind of below here. So now I'm doing negative I times x, negative xi, positive I, and then negative I squared. Okay, so we still have x squared. This and this cancel, this and this cancel. I squared is negative 1. Negative 1 times negative is going to be a positive 1. And so we can add 1 and 1 together to get 2, and this together to get negative 2x. Okay, so that's our first factor. That would be like this piece. Now do the next thing. So x squared plus x plus xi plus x plus 1 plus I, negative xi, negative I, negative I squared. Okay, we can bring down our x squared, and then we have x, those cancel, those cancel. This is like negative 1 times negative, so it's going to give us another positive 1. Positive 1 and positive 1 is positive 2. Then add those together, positive 2x. Alright, so just to write our final answer, if we multiplied these together, it would end up being this, but they don't ask us to do that, so we're not going to do it. They just wanted it as a product like that. Okay, and we have one more. It says find the 3 cube roots of unity and display them on an Argon diagram. Okay. So the nth roots of unity are the solutions to this. So what we want to find third root equals 1. And so if we do 1 is equal to cis 0 plus k2 pi, because if we're, oops, I don't need the circle right now. So if we're right here on the real and we want to go 1, our rotation is 0. Okay, so we're going to write z3 equals cis, I don't need the 0 anymore, k2 pi. Once again, k is an integer. Okay, now do the third root like that. And the Moivre's theorem, you've seen it a couple times, so I'm just going to kind of jump to this. Okay, now we're going to plug in 0, 1, 2, because we're only doing 3 roots this time. So if I plug in a 0, we get z is equal to cis 0. And if we plug in a 1, we get cis 2 pi thirds. And if we plug in a 2, we get cis 4 pi thirds. Okay. Now, keeping in mind that cis is cos 0 plus I sine 0. Cosine of 0 is 1. This just goes to 0. And so overall, this one is 1. For this one, it's going to be cos 2 pi thirds plus I sine 2 pi thirds. And so if we're on this diagram right here, 2 pi thirds is about 2, so with our estimation, it's going to be somewhere over here. And so if we take 2 pi thirds minus pi halves, common denominators, so that's 4 pi 6 minus 3 pi 6, so that's pi 6. And so it's our first rotation, which is symmetric with this one, which is 1/2 square root of 3 halves. And when it's over here, it's 1/2 square root of 3 halves, but the x is negative. And so this becomes negative 1/2 plus square root of 3 halves I. So that's what this one became. And then going through a similar process right here, 4 pi thirds is going to be about a 4. So it's somewhere in this quadrant, so we need to take out this, which is pi. So we're going to say 4 pi thirds minus pi, which would be 3 pi thirds. And so that's just 1, or pi thirds, when we do the subtraction. And so that would be the third, which is symmetric to that one. So it's just going to be negative 1/2 plus square root of 3 halves I. No, minus. because they'll both be minus down there. Okay, so those, we got those. Now if we read the problem, let's draw them on an Argon diagram. So our first one is just 1. So the radius of our unit circle, of our circle, will be 1. And we're told that these will be evenly spaced from this point. So the first one is right here, or the second one is right here. And the point is going to be -1/2 square root of 3/2. And then the other one's right here, where we have -1/2 square root of 3/2. Then this one is just 1, 0. Okay. And the next part of the problem, it says if W is the root with smallest positive argument, show that the roots are 1, W, and W squared, and that 1 plus W squared equals 0. Okay? So we're going to let W equal our second root, because we already saw that we have a root of 1. So we have roots of 1, W, and W squared. We've already seen the 1, so this one must be W. And then if we square that, we get cis 2 pi thirds squared, which, remember, we can bring that in with de Moivre's theorem. 2 times 2 pi thirds, and so cis 4 pi thirds, and so that really was W squared. Okay? And now we showed that those roots are what the problem asked for. And then if we do 1 plus W squared, we get 1 plus, what was the answer? I forgot. Right here. -1/2 plus the square root of 3/2 I. Oops. And then W squared is just the answer for the last one, which was right here. -1/2 minus square root of 3/2 I. And if we did, okay, so what, this was equal to 0, sorry, I forgot to write that. So that's what we need to prove. We need to prove that this really does equal 0. The parentheses are redundant on this, and so we can combine those. So we get 1 minus 1 plus square root of 3/2 I minus square root of 3/2 I. These are opposites, so they cancel. These are opposites, so they cancel. So 0 equals 0. And so we got it. If you need additional help, please come to Math Lab. Until then, calculate.